No, hello, hello, hello. Am I audible? So am I audible? Please let me know in the comment section, Anna. So sorry for the intervention. I think I have been changed the settings. That is the main reason. Uh, in the last video session, it is showing 360 view. That's why I've been created a new live session. Sorry for this some small interruption. So is my audio audible for everyone such that I can start the class and I can finish it by half an hour. So I won't take much time of you people. So let me, everyone, I think only Prabhas has been there saying yes. I want, you don't think it as like a normal YouTube lecture or etc. etc. I want you to be interactive. I want you to join with the curiosity to learn quantum computing. It is not about forcing you. It is not about attending, just marking your attendance. I want you to understand the concept. If you're having any doubt, let me know in the comment section. I can be answerable for any questions. But the thing is, I want you to be there. So shall I start, Prabhas? Someone can come and drop something in the comment section such that we'll start from. Hello, shall I start? Shall I start the session, Prabhas? Make sure your classmates have been joined. Thank you, Praveen. Pranavi, sorry. So thank you for your confirmation such that I will start the session. So I will start the session. Let them join as early as possible. So the first the first topic in our session is that I wanted to ask a question that why we need to learn quantum. So that is what the main question comes. Why? Because we are as nothing but we are CSC people, and why we need to learn quantum. So that is what the first question comes in our mind. So before going on to that, I want you to understand the history of quantum computing. So many of you think like quantum computing is completely a new technology. So, but actually, it is the result of thousands of years of development of computing. So, it is not a new technology. It is there evolving from years. In this unit, we will start from very first calculating device called abacus, and slowly we move towards quantum computers. And by the end of this particular unit, you will understand why scientists are building quantum computers and how they are different from quantum computer, how they are different from classical computers we use every day. So if you see here in this particular slide, before we start, I wanted to ask everyone one question. Can today's fastest computers solve every problem? Just think a question that I am asking you. Can today's fastest computer, which means it is like a 15 GBO, 16 GBO system, which is the fastest computer that is there in the market, can it solve every problem? That is what the first question I wanted to ask before going on to the session. So most of your students say yes. Why? Because you don't know how complex the problems are. You just see some real world calculations, very small calculations, and you say yes based on your assumption. Okay, fine, no issues. But the correct answer is no. Why? Because today's computers are very powerful. They can perform billions of calculations every second, but there are still some problems that are also difficult, that even the fastest supercomputer would take millions or billions of years. I have been stretching a word millions or billions of years to solve them. So the problem is not that computers are slow. So the problem is that some tasks become extremely large and complex, Nana. Throughout this unit, we'll understand why this happens, how quantum computing tries to solve the problems, and I want you to answer who thinks the answer is yes for this particular question. So please let me know in the comment section, Anna. So I want you to answer. Do you really think the fastest computer which is there in the market will solve every problem? I want this particular question answer to be answered from everyone. It should be not like I just speak and you just see, you just join the YouTube channel and just keep it aside. I don't want that to be happen in this particular session. Why? Because you are giving me the extra time. You should utilize that extra time too, rather than just time wasting. It is nothing if you waste the time. No, sir. Thank you. Thank you. Uh, I think some name is there. Thank you. No. Why? Because I know classical computers cannot solve every problem. So let us see what are those problems which they can solve, which they cannot solve. So why we require quantum computer? Why we require to learn quantum? So all those things will let you know, Nana. So now moving on to the third slide. If you see here, let's see what computers are good at. So a calculator, if you see here, if I, a calculator can multiply two large numbers almost instantly. So your mobile phone opens apps within seconds. If you see, if you open any mobile, if your mobile is strong enough, you can open any app within seconds, and your laptop runs many programs at a time. If you see, I'm running OBS Studio in at a time, and as well as live, as well as the PPT at a time. So these are happening parallelly. These are extreme. These examples of problems that computers solve very fast, right? Now look at the right side. If you see here. Can a computer perfectly predicts tomorrow's stock market? Why? Because we are accurate and we are fast, right? So can anyone say tomorrow's stock, for example, if I say tomorrow's stock price for this particular company will increase, if I will be giving only the probability by using classical computers, but I cannot say exactly what will happen tomorrow. Can it instantly crack every password? The classical computer? No. Can it simulate every atom inside a human body? No. Why? Because just think about a corona scenario that I've been mentioned in the class, in every class I've been mentioning. So during corona, we got medicine almost a 6 or 7 months after most of the people have been dead. It is not before 6 or 7 months itself, but it took long time to get a medicine, right? So why? Because we need to that particular medicine should suit everybody. So some of the people who has been vaccinated got heart strokes, etc., etc. That are the side effects of those things. So, but a quantum computer can simulate these things easily, such that we can find. I am not saying quantum computer is best computer, but quantum computer can make the possibility even good rather than making it worse. That is why we require quantum computer. So, and if you see here, let us assume a scenario. Imagine I will be giving three students uh, to solve a problem. So, for example, student A solves 10 sums per hour, and student B, same from the same class, student B solves 100 sums per hour. But whereas student C also solves 1,000 sums per hour. So clearly student C is much faster, right? Now imagine a question that contains 1 trillion calculation. Just imagine. So if I give just 1,000 sums, it will solve in 1 hour. But what if a problem is having 1 trillion calculations? Sometimes we need completely different way of solving this 1 trillion calculations. So that new approach is called quantum computing. So instead of making computers only faster, scientists change the way computers process information. So students C also require thousands of years to solve this particular 1 trillion calculations. So making faster is not at all an issue. So doing smart is an option. So for doing smart, we introduced quantum computing. That is the main reason of learning quantum computing in our curriculum. Now moving on to the journey of from bits to qubits. I've been mentioning here bits. So during the abacus, we used to use bits to calculate the plus addition or if subtraction or some other division calculations. We used to use bits. Now we'll be using just we are opening our calculator and just typing 3 plus 5 or 5 plus 6, etc., etc. The answers were coming in seconds, in milliseconds. But the journey when it is started, we used bits to compute all those things. Okay. So first thing we have been there started with abacus, sorry, and then we are traveled towards mechanical calculator. There we use gears to compute calculations, etc., etc. Then later after that, vacuum tube computers were being invented, and then scientists developed transistors, and after that then integrated circuits. In the same circuit we'll be having micro level integrations. And last, and this was the best uh, invention, which is nothing but microprocessors, which made personal computers possible. Right now we are using that are possible by because of the reason behind that is nothing but microprocessors. And today we have artificial intelligence. You already know, you already aware of artificial intelligence. And now we are entering the era of quantum computing. So this is the next era of quantum computing. So every new technology made computers. So notice this particular thing. So initially abacus was a room size thing to just calculate 2 plus 3, 2 into 3, 2 divided by 3, 2 minus 3. Now you can calculate it in a keypad phone which is very small and which can give you very fast answers. But if you see here, from long period, that's the size of the particular invention has been decreasing and the fastness of the invention has been increasing. So now the quantum computing is simply the next step in this long journey. So it is like, if you assume this quantum computing is like abacus. So how from abacus to artificial intelligence. So now the quantum computing is also evolving in the same way, right? Now moving on to the, let me give you the clear example, clear explanation about when the abacus has been invented. Okay. Now the abacus was invented around the 3000 BC. So it was one of the first calculating devices. So people, I've been mentioning, people used bets to perform addition, subtraction, multiplication, and division. So everything was done manually. So it was very slow. Next came mechanical calculator. So it was invented by Pascal. You already know his name. So instead of moving beds by hand, it used mechanical gates. This made calculations faster than abacus. Okay, although it was still slow compared to today's computers, but it was a huge improvement in that particular stage from 3000 BC to 1600s. It was the big invention. The mechanical calculator was the big invention. Now later on, uh, electricity entered into the picture. The first electronic computers used vacuum tubers. Okay, so a famous example is nothing but ENIAC. So that was the famous vacuum tube in 1940s. They generated a lot of heat. So by using this electricity, that room size vacuum tube computer is generating huge heat. So they also consumed huge amounts of electricity. And later that the transition has been came in 1947. Bell Labs invented transistors. So this changed everything. So this transistor changed everything. Transistors were much smaller. They were very cheaper. They produce less heat. Were also more reliable compared to these vacuum tube computers. Almost every modern electronic device today uses transistors. So in 1947, the transistor era has been begun. Now, later on that 1990s, after transistor, scientists developed integrated circuits. So instead of using it one transistor, they place many transistors in one chip, that is called as integrated circuit. So this made computers much smaller and much powerful also. So after that, by inspiring from this, so in 1971, Intel 404004, which is nothing but the microprocessor, has been invented. So a microprocessor that contains the entire CPU on one chip. That is what the best invention of our latest technology that we are using as of now. Because of microprocessor, personal computers became possible. Today, every laptop, desktop, smartphone contains a microprocessor. So this era was a complete different era as we are now. Why? Because as we are using mobile phones, laptops, etc., etc. Why? Because of this particular era, the microprocessor era in 1971. And later that, you already know, uh, we are using artificial intelligence in in a day life. You already know examples that include ChatGPT, Google Translate, face recognition, even self-driving cars uses AI. So AI helps computers learn from data, but AI still runs on classical computers. You already know. You can use this in your desktop too. Now scientists are developing, this is where you need to focus. Now the scientists are developing quantum computing. So instead of using ordinary electronics, so quantum computers use the principles of physics. You already know the fundamentals of physics, right? Superposition, entanglement, uncertainty principle, wave particle duality, and quantization. These are nothing but the fundamentals of quantum physics. So their goal is to solve certain complex problems much faster than classical computers. Okay. So just now I have been mentioned for a student C, it takes thousands of years to solve it 1 trillion calculation. So such type of problems we can solve by using quantum computer even in a millisecond. So in future, AI and quantum computing may work together. Okay, that is what you need to remember. That is the main reason you need to learn quantum. So in future there will be some roles also like quantum integrated AI role, quantum AI role. As of now, machine learning data scientist, ML engineer, some roles are there, right? Even in future, you it may replace they may replace by quantum also, quantum engineer, quantum AI engineer. So such type of things may be also coming in future. It is not much far. Okay, so that's why you need to focus, you need to try to learn something from the session. That is what the main intention is. Now, if you see here, I've been given one thing in the slide. If you see, let's understand a real world example here. Suppose your password is 1234. So there are only few possibilities, okay, and few combinations in this particular password. Now, if I give, if I run an algorithm and if I ask the algorithm to crack this password, it may be simple. It may not take much time, much epochs. Okay. But now imagine these ABC 123 XYZ at the rate 786. I wanted to guess these possibilities. It is impossible, right? So a classical computer checks one password after another. So this method, so checking one password after another is called brute force. So a computer checks combinations one by one, that we call it as brute force. Okay. So that is nothing but practically it is impossible to crack this particular password which I have been showing on the screen. So quantum computers do not simply try passwords one by one, they explore possibilities in a fundamentally different way, which is why researchers believe they may solve some problems much faster. That is the main intention of inventing or studying quantum computing. So if you see here, until now we have discussed the history of quantum computers, Nana. Now a new question comes into our mind. Where did quantum computing actually come from? That is what the main question. Did someone suddenly invented it? No, I say my answer is no. Why? Because quantum computer was born because scientists were discovering something very strange about nature. Around 1990, around 1900 itself, scientists started studying extremely tiny particles like atoms, electrons, and light. They noticed that these tiny particles do not always behave according to normal rules that we can see in everyday life. This led to a completely new branch of science called quantum mechanics. So if you see here in 1900s, Max Planck he proposed that energy is not at all continuous. Instead, energy comes in tiny packets. So he called these tiny packets called quanta. So the tiny packets that called quanta, the energy is not continuous. So it is coming in packets. That packets is nothing but quanta. So later after that, this was the first step. So Max Planck was the first step in quantum. Later after that, in 1905, Albert Einstein he explained photoelectric effect, which means till then many of the people believe that photon is nothing but light travel in wave only. But Albert Einstein proved that photon is also traveling in particles. So he showed that light behaves like tiny particles called photons also. Until then, many people believed that light was only wave. So Einstein proved it also behaves like particles. Okay. Then in 1924, Lewis D. Broglie uh, made another surprising statement, and he said matter like electrons can also behave like waves. Okay, so imagine this like light behaves like particles, matter behaves like waves. This was very surprising for a engaging user who is listening to the concept newly. So later on that 1926, Erwin Schrödinger developed the famous wave equation. Okay, even today particular equation is using widely. And later on that in 1927, Werner Heisenberg have proposed uncertainty principle, which means we cannot measure exact position as well as momentum at the same time. So as I already mentioned in the class example, if there is if there is a fan in your room, let you see on the top, you will be able to see three wings rotating on your head, on the top of your head. If I stop that fan and I mark every let us say every wing has wing 1, wing 2, wing 3, and I keep that fan momentum the race at 5, and I want you to stop, or I want you to say exactly where one is moving and what is the speed of that one. So it is not possible. That is what that Eisenberg uncertainty principle have been stated eh, during 1927. Later on that in 1935, these scientists were not building quantum computing computers, they were discovering how nature works. Okay, rather than just putting or showcasing something that no that they have been known, but they have been started discussing how this particular nature works. So years later, computer scientists used to discover to build quantum computers, etc., etc. Okay. Now, can anyone tell me which scientist introduced the idea of energy packets called quanta? Can anyone from the audience? Mhm. Can anyone who introduced the quanta concept? I want you to answer in the chat box, Nana. Who introduced the question is who introduced the concept of quanta? That is what the simple question I've been asking you people. So please, Nana, it is not like a one-side war. It should not be like one-side war. I want you to be active, proactive in the comment section too. So rather than active, having actively participating in Insta, I want you to be there in uh, YouTube also, in my live also. Max Planck. Still someone? Still anyone having some known answer? Throw into the comment box. I think almost the answer is correct, but someone, e- even though the correct answer is visible, so many of you are not coming to the comment section. I want you to come to the comment section such that I will be understanding whether you are listening or not. That is what, if the main intention is to make you people understand, it is not like just coming to the class, saying and going. I don't like that particular. Janvi and Madhu. So I think they have been answering Max Planck, Max Planck. Okay. So the correct answer is nothing but Max Planck's, Nana. So Max Planck has been introduced that the energy is not coming in just like waves. It is coming in quanta, which is nothing but the particles. Okay, packets. Now moving on to the main theorem or main focus of quantum computers. So now quantum computer. So till now we have been seen that quantum mechanics already existed, but nobody had thought about making a computer using these principles. So then one scientist changed everything. So you need to remember the scientist's name. His name is nothing but Richard Feynman. Okay, Richard Feynman. So you should not forget his name. So Feynman asked a simple question. So nature itself follows quantum physics. So why we are trying to simulate nature using ordinary computers? So why we are not using these particular atoms or molecules, etc., etc., for doing some computer tasks? So this question made realizing for many of the scientists, and this is where we call it as the birth of quantum computing too. Okay. So his famous statement was, if you look here, nature isn't classical. If you want to simulate nature, you would better make it quantum rather than we are making it classical. Classical, if I on the switch, the fan will rotate. If I off the switch, the fan will stop. That is what we call it as classical, Nana. But moving on to quantum, it will be like in superposition. Superposition, this is two states at a time. So that is what the nature having for quantum particles. Why we can't simulate by using this nature itself? Why we can't simulate a quantum computer? That is what the main question has been asked by Richard Feynman, and that uh, idea became the birth of quantum computing. So in 1980, it will be MCQ question. It will be Pakka question. I've been mentioning again and again. In which year I may ask, in which year or which scientist, or I may ask you fill in the blanks, etc., etc. too. So please make sure you don't forget this name, Richard Feynman. So this is where the birth of quantum computing has begun. And later after that, David Dutch in 1985, you just like a normal computer, uh, he has been invented a universal quantum computer model into the market. So he imagined a quantum computer that could also solve many different quantum problems. So it is not like it is just not to make fast. It can also solve many problems. David H has been introduced that universal quantum computer model, and later on that 1994, sorry, Peter Shor created Shor's algorithm, Nana. This is very, very important algorithm that is there in Unit 3 and Unit 4. You please remember, this will be a Puka question in your exam. So the algorithm became famous because it can factor very large numbers much faster than classical computer. That is what I mentioned. So if it is a big number which is having 100 numbers also, it can factor easily. Peter Shor algorithm. So that is where questioning comes in many of the end-to-end encryption users. So end-to-end encryption will be completely working using this encryption model, Nana. So that encryption model also will be broken by Peter Shor algorithm that has been shown theoretically. But if what if someone shows it in practically? So our economy system will be broken, our RBI system will be broken. Why? Because every system now, even our social media accounts, everything uses end-to-end encryption. If that happens, it is completely gone. That is the main reason governments are also running and rushing towards quantum computing, such that they can save their systems by building their infrastructure. That is the main reason. And later after that, Low Grover has been introduced Grover search algorithm. This is also very important algorithm, Nana. Suppose, let us say, if you lost a phone with 1,000 boxes, let us say, if we are having in a room, if there are 1,000 boxes, in the 1,000 boxes, there will be a phone hiding in the 1,000 boxes. So classically, we'll go through every box and check if there is no phone, we'll close it, then we'll go to the next box until you find the phone. But whereas Glover Search algorithm makes that task very simple. So I will explain all those things in the unit 4, and later after that, this is where uh, the main thing has been shown into the market by Google. So Google in 2019 announced quantum supremacy, Nana, using Sycamore processor. So it does not mean quantum computers are better at everything, but it simply means that for some specific problem, a quantum computer completed the task much faster than world's best classical computer, Nana. So if you see here, so they performed one task and they are given that same task to classical computers. Classical computers, in the sense, very super fast computer as of now in the market. So a Google's Sycamore quantum processor has been done that particular task in just 200 seconds. Just believe it has done just in 200 seconds, and it is estimated thousands of years classically, which means for a supercomputers, which is the super ultra most computer in the market right now, may take thousands of years. How fast a quantum computer is. That is why we need to learn quantum. Now, before going on to the next slide, I want you to answer who is the father of quantum computing. You please answer who is the father of quantum computing, Nana. So I want you to answer in the comment section who is the father of quantum computing. Good number is increasing, but I want you to answer Nana kotta kochina vallu. So please be active in the comment section too. Hi answer. Who is the father of quantum computing? Just now have been mentioned. No, David. Wrong answer. Wrong answer also accepted, Nana. No issues. No issues with the wrong answer. Just you need to try. David Dutch. No. Who is the father of quantum computing? Not David Dutch. This not at all correct answer. Still, any answers? Who is the father? Who is the father of quantum computing? That is what I'm asking. Or simply I can ask who is called the father of quantum computing? Pranavi is the, I think, Pranavi, Sandhya Jobins. The answer is nothing but Richard Feynman, Nana. So Richard Feynman is called as the father of quantum computing. And why? Because he believed that why we can't use nature, or why we can't use nature particles for quantum computing rather than using some other particles in classical computing. Why we can't use the nature given particles for doing some calculation? That is where the idea has been born. That is where that quantum has been evolved. Okay. So good, Nana, good, good. So Peter Shore, Nana, Peter Shore, it is not the right thing. Why? Because Peter Shore has been shown that our end-to-end encryption that we are using as of now, even in YouTube also, we'll be having end-to-end encryption. మీరు చూస్తూ ఉంటారు నా వర్డ్స్ చూడండి ఒకసారి. If you go through WhatsApp, you'll be, if you open settings at the end of that, if you scroll down at the end of that particular tab, you will be able to see end-to-end encryption. What that means, so we'll be having a encrypted key that a classical computer may take thousands of years to decrypt it, which means it is impossible to hack WhatsApp or Instagram or PhonePe or etc. etc. But Peter Shore algorithm ఏం చెప్పాడంటే we can figure it out by making it into factors, and we can find the exact key within seconds. So the practical ga is shown, is shown it in theoretically 1996 itself. So but what if someone tries to implement using a quantum computer? That is where the concern has been come from. So ఆ కన్సర్న్ వచ్చినందుకు ఈవెన్ గవర్నమెంట్ స్టార్టెడ్ ఇనిషియేటింగ్ దిస్ క్వాంటమ్ కంప్యూటింగ్, అండ్ గవర్నమెంట్ స్టార్టెడ్ ఎవ్రీ వన్ వాంట్స్ టు లెర్న్ క్వాంటమ్. అందుకోసమే ఎవ్రీ వన్ ఎవ్రీవేర్, even in the curriculum, in B.Tech curriculum, even though you are CSC people, that quantum computing has been injected. Why? Because you need to know, you need to be aware of quantum. That is the main reason, Anna. Okay. Manjunath Reddy, hi. Save trees, thank you. Richard Feynman is the right answer. Mohit Sriram, hi. Hi Ganesh. Okay. Chala inga. So I want you to be active in the comment section also. Okay. Lana, let's move to the main thing. Why this particular word? Why we called it as quantum? So the word quantum comes from the word quanta, Nana. So you've been seen the energy the particles of the energy is nothing but quanta and Max Planck. So from there they have been extracted quant. Okay, from that word, the quantum lo quanta ane padam vachindana. So a quantum means the smallest possible packet of something. Okay, the smallest. So listen carefully. A quantum means the smallest possible packet of something. Let's understand it using examples. Examples ichano. So matter is made of atoms, anna. But atom contains electrons. Light is made of photons. Okay, but energy exists in tiny particles called quanta. So quantum computers directly use these tiny quantum particles to process information. Now we are using bits in our classical computer. Bits are nothing but binary digits that are nothing but 0 or 1. But in quantum computer, we'll be using these type of things on atoms, gani, electrons, gani, molecules, gani, okay, light, gani, photons, gani, energy name quanta. Okay. Unlike classical computers, which only use electrical signals, quantum computers use the behavior of electrons, photons, ions, or superconducting circuits. I will be letting you know all those terminologies in the coming classes. Don't bother about the terminologies that I have been using now. Okay. So that is why we call it as quantum computers. Okay. Quantum is nothing but digging the information from the known smallest particle. So, for example, let us say, I'm assuming I'm a CID officer. I've been entering into the crime scene. So, quantum is like it won't see just the particles that are visible, but quantum is nothing but it will dig the smallest or unknown clues too. So that is what the meaning of quantum is. Okay. Now, if you see here, the this is the one of the important slides. Now, ఒక్కసారి చాలా careful గా చూడండి. If you see here, look at this numbers, Nana. First, so one electron has two states: ground state, excited states. But if you go to two electrons, it may having two electrons and four possibilities, three electrons and eight possibilities. and 4 electrons and 16 possibilities. If it is 5 electrons, it will be having 32 states. Okay, which means, can anyone notice the pattern here? If you see here, 2, if again 1 electron is increased, it is increased by 2 into 2, and again into 2, and again into 2, and again into 2. So this is the pattern. If you observe here, you are getting a pattern. And I could just say you are getting a pattern such that it will be looking like, if you write 2 power n. So 2 will be the base. If elect 1, if it is n is equal to 1, the answer is 2. If n is equal to 2, the answer is 4. If n is equal to 3, the answer is 8. If n is equal to 4, the answer, which means it is the qubits or the quantum bits will be working on this exponential formula. But whereas a classical bit will be working on this operation 0 or 1, just 0 or 1, that's it. But ikkada we'll be having 2 power n possibilities for every computing. So that is what I have been given here. Okay, for 1000 particles, let us say it required 2 power 100 for 100 particles, which means we will be having 1.267 into 10 to the power 30 states. For a classical computer, just to compute it, it may take 10 years or 100 years. Okay, but for a classical quantum computer, it can take only 1 second to compute it, Nana. So that is why classical computers struggle to simulate molecules, proteins, or chemical reactions. This is what exactly the problem Richard Feynman wants to solve, Nana. That is the main reason Richard Feynman has been stated why we can't work with nature, why we are going against nature and creating some classical computers and making them to work as a quantum computer. Why we can't use nature particles that nature has given to us. So that is where the birth of quantum computing has been involved, and that is the reason. If you see here, so for a classical computer, for example, if there is 5 electrons for a classical computers, this need to go to 32 it needs to visit 32 times simultaneously or sequentially, such that it can give some conclusion. But for a classical computer, it may not take much time. Why? Because it goes at a time. 32 ఒకటేసారి possibilities అనేది possible అవుతాయి నాన్న. That is what I have been mentioning here. That is the main reason we require quantum computers. Now moving on to Richard Feynman idea. Here I've been mentioned again one more slide. So Richard Feynman gave one brilliant idea, Nana. Instead of using ordinary bits in the sense 0 or 1 in this particular example. So why don't we use quantum particles themselves to perform calculations? So this particular famous statement, nothing but nature simulates nature, which means nature itself giving us atoms, molecules, ions, or photons, etc., etc. Why we are using another electrical signals that are made artificially to compute the task? That is what the Richard Feynman has been questioned the scientist. So that is what that is where this became the birth of quantum computing. Now, if you wanted to study fish, let us say, it is easier to study them in water or land. Just imagine, if you wanted to know about a fish, will you go to the underwater or will you go to a land? So you go to water, right? So similarly, if you want to simulate atoms, it is easier to use quantum system rather than using a classical system. That's the simple idea, and that became quantum computing. Okay, rather than taking these atoms or molecules and testing it on classical computer, why we can't use a quantum system that such that a quantum system can understand the quantum particles? It will be easy, right? So instead of searching a fish in water, what is the reason we are searching the fish on the land, which is not having any possibility? So that is what the question of Richard Feynman in the 1900s. So that is the birth of quantum computing. That is where the birth of quantum computer. Many scientists realize the question is good, the question is correct, that our Richard Feynman has been mentioned, and from there the evaluation of quantum computing has begun. Okay, now let us move to the first important topic. Sub, what is the requirement of maths, physics, and biology in quantum computing? So we require this Three subjects to complete quantum computing, Nana. If we miss any subject, we cannot do. So mathematics helps us to describe, calculate, and describe and also calculate quantum systems. Whereas physics help us how quantum particles behave. చెప్పిన atoms, molecules అన్ని కూడా physics కిందకి వస్తాయి. And even biology help give us real world problems where quantum computers can be useful. As I mentioned, corona time lo, it is very difficult to test thousands of molecules which are there in our body. And వాళ్ళు ఏం చేస్తారంటే జస్ట్ శాంపుల్ సైజ్ గా తీసుకున్నారు, శాంపుల్ సైజ్ గా మెజర్ చేశారు, and based on the sample size they have been introduced a vaccine into the market. That's it. But they haven't tested on thousands or lakhs of people. Why? Because there is no time. So that is where in biology, quantum computers can help, can play a major role in the future. So this is what the major advantage, Nana, in biology, right? Especially biology. So without mathematics, we cannot make calculations. Without physics, we cannot build. Without biology, we may not know where to apply this technology. Why? Because the main intention of quantum computer is nothing but to improvise the biology or medical industry. Okay. So we may not know where to apply these technologies. So quantum computing is truly an interdisciplinary field, Nana. Why? Because it will be combining of, it is the combination of mathematics, physics, as well as biology. That is why I'm calling it as interdisciplinary field. Okay. Now moving on to the first important thing is nothing but why we require mathematics. Okay. Actually, this mathematics is nothing but the language for every computer, Nana. If I wanted to compute or if I wanted to talk to you people, I can speak in English, you can understand. But for a quantum computer or any computer, mathematics is a language to communicate with a computer. So whenever you open Google Maps, let us say one example have been mentioned here, if you see in the slide. So whenever you open Google Maps, use YouTube, send WhatsApp message, or even withdraw money from ATM, mathematics is working in the background. Remember this. Similarly, quantum computing also cannot exist without mathematics. So first thing is nothing but mathematics help us describe quantum systems. What are the probabilities of quantum system, etc., etc. Let us say, how tall is the building? Can quantum computer understand without mathematics? No, right? So you must say 20 meters or 3 floors, etc., etc. And how heavy is the bag? Let us say if I show to the quantum computer without having mathematics, I am asking him to calculate or compute the weight of a bag. Is that possible? No, right? So everything that is the main reason we require mathematics to describe the state of qubits. Okay. Without mathematics, scientists cannot even explain what a qubit is. Why? Because given qubit also, we will be expressing it using ket 0 and ket 1 notations, right? So second point is nothing about mathematics is used to represent qubits. You already know the classical bit can be either 0 or 1, but a qubit can exist in combination of both states, that we call it as superposition. To represent this combination, we use mathematical equations and vectors, Nana. So that is why we require mathematics. From now, uh, just remember the mathematics is needed to represent quantum information. That's it. Don't think much about the mathematics. Okay. So mathematics help us to calculate probabilities. Why? Because in classical computer, we'll be getting exact outcome. Whether I may fail, whether I may pass, it will be showing exact outcome. But here, we only get the probabilities. For example, let me give a scenario, and the quantum computer predicts whether I will be passed or not based on my study hour, based on my uh, 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 knowledge, based on my intentions, based on my let us say study hours that I've been keeping on my particular subject. So no, the quantum computer said this quantum computer says the probability of Ramu passing this particular test is 80. The probability of failing is 9. Why? Because the combination should be equal to 1 according to Bond rule. Okay. Now if you look here, every quantum algorithm is built using mathematics, Nana. So algorithms like Shor's algorithms, Grover's algorithm are full of mathematical concepts. Without mathematics, designing these algorithms is impossible. So if you see here, if I mention a Google Maps example here, suppose you wanted to travel from your home to particular, let us say your college point, let us say. You open Google Maps, within second it tells you how the shortest route is and what is the distance from the home to your particular college distance or estimated travel time for your distance. And even it will show you the alternative routes also. Okay. But don't follow that alternative routes. It may be causing you harm. Okay. So does Google Maps guess the answer? That is what the main question I wanted you to ask. Does Google Map guess the answers? I want someone to answer, Nana. I've been mentioned if I wanted to travel from A to B place, let us simply say. So like it will give you the shortest route. It will say the distance is 10 kilometers. It will say the estimated time is uh, someone is promoting my channel. Like and subscribe, guys. And now my question is, does Google Map guess when you type a location from your home to some other destination? Does it guess the shortest route? Does it guess the distance? Does it guess the time? Does it guess the alternative routes? Can anyone? Nana? Yes or no? Please let me know in the comment section. Someone please answer me so that uh, Nana, someone please answer me. Yes, guess yes Sunda. Correct is Sunda. That is what my question is. Praveen, Pranavi, does it really guess? Randomly guess yes Sunda. Salman Khan, yes. Okay, no issues. It will guess shortest distance. Okay, Salman, no issues. Correct one. It will guess, right? So let me give you the answer. Okay, don't stress much. It won't guess. Okay, it will give you, it will be performing millions of mathematical calculations in the background. So the answer that you have been mentioned, it is guessing and giving, it is wrong answer, Nana. So even a classical computers as of now, which we are using in our phones or etc etc, completely they will be working on maths. So the in the background it won't guess, it will give you the exact calculations. Okay, so that is what the small corrections you need to make, it won't guess. Similarly, a quantum computer also uses mathematics to calculate quantum states and solves some problems. So mathematics, so remember this particular point, mathematics is the language that help us describe and calculate everything inside a quantum computer. So that is the main reason we require maths. Okay. Now moving on to the importance of mathematics, the importance of physics. So now let's move to the second pillar, which is very physics, which is the main pillar, I will say. If mathematics is the language, then physics is the science behind quantum computing. So think about this like, can you build an aeroplane or airplane without understanding aerodynamics? Can anyone say? Can you build an aeroplane or airplane or helicopter without knowing or without understanding aerodynamics? Can you build it? Anyone? Let me know in the comment section. Can you build an aeroplane without studying aerodynamics? Yes, no? Please be active in the comment section. No. Gautam, I think the answer is no. We cannot build an aeroplane or a helicopter without knowing aerodynamics. Okay, no, no is one answer. Someone throw some wrong answers to the comment section, such that we'll be making it very clear. Someone throw some Salman Khan, nice. No, it's impossible, right? Why? Because without learning aerodynamics, how it is possible to build or to have that particular aeroplane or some helicopter, right? It is not possible, right? So same way, uh, I've been asking again another question. Can you build a bridge without understanding engineering? Can you build a bridge without understanding or without studying in civil engineering? Yes, no. Is that possible? Come on, Anna, yes or no? Just answer me yes or no. Make it fast so that we'll finish as early as possible. I think we are at 17th slide, almost done. Is it possible to build a bridge without having note at all? It's nice, nice, Nana. Super, super, Bunny. Bunny Jan, dance. So super. No, it is not possible, right? Why you are thinking that much or why you are making your mind to think that much in a wrong way? So, similarly, the answers that you have been given, no. Same way, we cannot build a quantum computer without understanding physics, Nana. So physics is nothing but like a bridge. Just think if in this particular two example that I've been asked you. So it is like a bridge. Okay. So quantum computing is completely based on quantum mechanics. That is what you need to understand. So quantum physics explains how tiny particles behave. So the tiny particles are nothing but electrons, any photons or ions, atoms, etc., etc. So scientists use these particles as qubits. So physics tells us how qubits behave. Okay. So physics also explains some special quantum properties. These include, as I already mentioned, superposition, entanglement, quantum measurement, or uncertainty principle, quantization, wave particle duality. So don't worry about these particular sounds. We'll learn each one in detail in later units. Okay. For now, just remember that all these concepts come from quantum physics. So let's take a simple example. I've been given it here as one electric fan. So if you on an electric fan, immediately the fan starts rotating, right? Why? Because the electricity flows through the motor. So physics explains how electricity flows, how the motor works, why blades rotating. Okay. Similarly, physics explains how quantum particles move, how qubits perform computations. So physics is not only helping us understand nature, it is helping us to build quantum computers. So without mathematics, we cannot calculate. Without physics, we cannot build. Both are equally important. So now, can anyone say me one answer? What happens if electricity is removed from the fan? Can anyone? What happens if electricity is removed from fan? What happens to the fan? Please let me know in the comment section, Anna. What happens to the fan if electricity is not being supplied? Come to the comment section, Anna. Please be active in the comment section. What happens? That is what the question I have been asking. What happens if electricity is not being supplied to the fan which is rotating? Gautam, Bunny, from someone come to the comment section, Anna. Fan will not work. Save trees. What is your name? Please let me know, Nana. Save trees. I want you to be with your identity. It will stop rotating, right? Same way, if there is no physics, there is no quantum computing. That's it. Simple. So that is what the conclusion I wanted to make. If there is no physics, if I stop electricity, the fan will stop working, right? But if quantum physics didn't exist, could quantum computing also didn't exist? That is what I wanted to make the clarity. Okay. So that is how important the physics is in quantum computing. Now moving on to the third technology or third importance one is nothing but biology. So biology, which is nothing but it is a application oriented, but whereas mathematics and physics is completely basic that is required for a quantum computer. Biology anedi will be implementing this particular physics and maths on biology. So biology wala biology lekapothe quantum computing ఉండదంటే it is not the thing. Okay. బయాలజీని మనం క్వాంటమ్ కంప్యూటర్స్ లో ఎలా వాడాలో చూస్తున్నాం అంతే. ఓకేనా? సో now many students get surprised. They ask like, why we need to learn biology? That is what the major question comes. So the quantum computing is related to computers, right? Why we are studying biology? Can anyone? Can anyone say why we need to learn biology? Why it is important to learn biology? So just now I've been mentioned maths is important for this particular task and Japan, etc., and Japan. And I also mentioned that why physics is important, what is the requirement of physics, Japan. But now, why we require biology? That is what the main question comes to my mind, and I will be throwing into your mind too. Can anyone please answer me in the comment section such that it will be interacting? Still, I see less participation in the live session. No issues, but later on that it will be having the recording will be having in the same channel itself. So please do watch, Nana. Why? Because the particular to know about our body parts, sir. Okay, okay. No, no, no. Okay, biology is important to know about your body parts, right? But the thing is, uh, why we require biology, why it is important, that is what I've been mentioned. I've been said that three pillars of quantum computing are nothing but mathematics, physics, and biology. Why it is important? To know human health, okay. One answer, Pranavi, nice. Drug improvement, okay. To understand human body, okay. Research. So that is what I got some answer here. Here, Shivakumar, nice answer. I think you've been answered good. Research. Why? Because so inventing quantum computer is fine, but where we need to implement. So we can implement in biology or medical sector. Why? Because medical sector require n number of or trillions of calculations to be done to invent a new drug to the market. Drug in the sense medicine. Okay. So scientists are trying to discover new drugs before releasing one medicine. They may need to test millions of possibilities, Rana, millions of chemical combinations. So, but whereas a classical computer takes a very long time to just simulate one molecule, but a quantum computer may perform these simulations much faster. That is why we require biology. That is why biology is important in quantum computing. So quantum computing can also help in, I've been mentioning in the classes also, DNA analysis, protein folding, disease prediction, and personalized medicine also. For that particular, all those areas, we require massive computations. So I've been given, I already mentioned in the starting itself. So let's remember the COVID-19 pandemic, Nana. Scientists had to develop vaccines very quickly such that they can prevent the deaths. So before choosing the correct vaccine, they had to test or they have to study thousands of molecular interactions. This require huge computational power, Nana. So quantum computers can simulate these molecular interactions more efficiently. So which helps scientists identify promising drug discovery. So rather than waiting for 6 months or 7 months, we can expect some medicine to be come into the market within 1 week or 2 weeks. So which means the death rate will be decreased, right? So that is why quantum computers don't directly create medicines. They help scientists analyze possibilities much faster. This can reduce research time. I think Shiva has been answered the perfect answer. The answer is nothing but why we need to learn biology is nothing but for doing research. For testing some thousands or trillions of molecules, we require research. For research, the classical computer may take years, but a quantum computer can take less time compared to a classical super fast computer. Now, can anyone please answer me? Can quantum computing replace doctors? Can quantum computing replace doctors? వద్దురా వద్దురా ఈ క్రింజ్ వద్దురా మనకి. అన్నం లేదు, పెరుగు లేదు, క్వాంటమ్ సార్కి తిరుగులేదు. వావ్, సూపర్. విచ్ ఇస్ ద బెస్ట్. చైతన్య కుమార్ రెడ్డి. You meet me when I'll be there. You'll meet me once. So trials is also correct answer. Good answers. Number of combinations is also good answer. I've been not seeing the comment section. అరే నువ్వు క్లాస్ అయిపోయినాక కలరా నేను పెరుగు ప్యాకెట్ ఇప్పిస్తాను అన్నం ఇప్పిస్తాను. Okay. Bharadwaj said no. Okay. Bunny also saying no. Save trees. Save trees. I wanted your name to be displayed here. Can you please type your name so that I can be speaking with your name? You are being active, very active. Sandhya, no. Okay. So quantum computers are not going to replace doctors. Okay, fine. Why? Can anyone? Can anyone guess why we cannot replace quantum computers? Or why we cannot replace doctors? No, no. Okay. Lavanya, no. Super. I've been getting good responses. No, no. Okay, fine. No. Why? My answer is why I want. Why you people are saying no? Hey, Babu, comment delete చేయొద్దురా. Like, that cringe comment should be there in the session such that the session will be having some laugh, etc., etc. Okay, because they can only assist. They can only assist doctors. No, not that. That is not the reason. Still, anything. Someone Lavanya has been getting the right point, but still think Lavanya is something there to dig. You can dig such that you will be getting some answer. You are almost close to the answer. More accurate. Okay, not about replacing. So that is what that is what what I want the name now. Dance DH for the LP, please, and also save trees. Please let me know your names in the comment section better. Almost, I think I got the correct answer here. So that is nothing but I can say no. The answer is no. It is 100% perfect. Everyone got the perfect answer, but it only helps doctors. That is what the last answer I've been got from the answer. Something the username is the answer. I think I guess. So researchers make better decisions. So what does quantum computer will help you in just discovering the molecule. So it is saying that particular molecule is good for health. That's it. But quantum computer cannot say exact answer. That is why quantum computers will not replace doctors. That is the answer. Okay. Now, moving on to some quick revision here. If you see here, before moving ahead, I will let me revise everything that we learned. So we have discussed three important subjects. One is mathematics. Another one is so mathematics is nothing but help us to describe quantum state, represent qubits, calculate probabilities, and design algorithms. Remember the Google Maps example. Okay. Without mathematics, Google Maps cannot be finding the shortest path. Okay. Now moving on to the physics. Physics is nothing but physics explains how quantum particles behave, how qubits works, and even how quantum computers operate. So remember the electric fan also. So without electricity, the fan cannot work. Similarly, without physics, quantum computing cannot exist. So biology already that I have been discussed just now. Now moving on to the main topic, which is nothing but introduction to quantum computing, Anna. So finally, after learning the history and the foundations, we are ready to uh, answer the most important question: what is quantum computing? So a quantum computer is a computer that uses the principles of quantum mechanics to process information. So quantum properties is nothing but superposition, entanglement, bioparticle duality, and also wave uncertainty principle and uh, quantization. These are nothing but the principles of quantum mechanics. Now, I will explain all those things in the second unit. Don't worry. So a classical computer stores, if you see here, classical computer stores information as bits. Already you know what are those bits, 0 or 1. But a quantum computer uses qubits. That is what the first difference. So classical computers use bits, but whereas quantum computers uses qubits. That is what the new notation coming into the picture. So a quantum computer, a qubit is different because it follows the rules of quantum physics. So I've been mentioned the rules of quantum physics and nothing but superposition, entanglement, one, etc., etc. So quantum computers are not better than classical computers at everything, but your laptop is excellent for watching videos, coding, browsing in internet, writing assignment, and playing games. But a quantum computer is not designed for these everyday tasks. Instead, it is designed for every specific problem that are extremely difficult for a classical computer. Just now, as mentioned, Corona time. So during Corona, it took almost 8 months to just discover a vaccine which is not 100% perfect. So such type of things, it is the quantum computers make very huge impact. So already I mentioned drug discovery. So scientists can simulate molecules faster to help discover new medicines. Anna. Even cryptography. So quantum computers may one day break some current encryption method that I've been mentioned. So source algorithm, so algorithm, so we can break our end-to-end encryption. So that is why we require quantum computer to protect our our security. And then moving on to artificial intelligence, we require this artificial intelligence to be used in quantum computing such that we can make wonders. And moving on to the weather forecasting in the sense, for example, if I said in the next minute it will going to rain, it should rain. That is what I require using a quantum computing. Okay, and another one is financial optimization. So bank can optimize investments and reduce financial risk also. And last but not least, scientists research. So scientists can simulate atoms, molecules, and even chemical reactions much more effectively, such that they can find the new medicine within the effective time. It won't take much time, more than a week. Okay. So that is what. So always remember this particular sentence: a quantum computer is not a replacement of your laptop. It is a special purpose computer designed to solve certain extremely difficult problems much faster. Okay. Now, moving on to the next slides. If you see here, so far we have learned what is quantum computing is, and now let's understand why it is faster using this simple example on the screen. So imagine there is a huge library with 1,000 rooms, Nana. Okay. Imagine there is a library with 1,000 rooms. So your friend is hiding in one of those particular 1,000 rooms. Just imagine 1,000 room library లేదు మన దగ్గర ఉన్నది 1 room library, but imagine 1,000 room library వాడు ఎక్కడో దాక్కున్నాడు. So your job is to find your friend, Nana. Let's first thing as like a classical computer. So మనం ఏం చేస్తామంటే first we go to room number 1 and search. If your friend is not there, you will go to room number 2 and room number 3 and then room number 4. It continues until it finds the correct room. So now imagine your friend is hiding in room number 10,000. Okay. So the classical computer may need to check every room. So this takes long time, Nana. So now let's think like a quantum computer. So a quantum computer uses the principles of superposition. So superposition and interference, and a superposition in the sense many possibilities at a time. We call it as superposition. And I'm not saying it literally opens 1,000 rooms at the same time, but that is a common misunderstanding. Instead of it explores many possibilities together using quantum mechanics. So the many possibilities ఇక్కడ నుంచి వస్తాయంటే నాన్న సూపర్ నుంచి వస్తాయి. So this allows certain such problems to be solved with a far fewer steps than a classical computer. So quantum computers don't magically know the answer. They simply use completely different methods of searching. ఇక్కడ మనం ఒక రూమ్ నుంచి ఒక రూమ్ ఒక రూమ్ నుంచి ఒక రూమ్ వస్తున్నాం, బట్ క్వాంటమ్ కంప్యూటర్స్ లో విల్ బి యూజింగ్ క్యూబిట్స్. క్యూబిట్స్ ఏం చేస్తాయంటే ఒకేసారి 1,000 ఉంటే ఫర్ ఎగ్జాంపుల్ 500 మెంబర్స్ ఒకేసారి పంపిస్తాయి. After that 500, then again the 500 will go to another 500, which means the search engine makes very simple. So in classical it will be simultaneously doing, but whereas here we'll be doing slowly. At a time, many possibilities such that we can explore that particular hiding person within a less span of time compared to the classical computer. That is what the major difference of why we required quantum computing, Anna. Now moving on to another example, if you see here. Now let me ask you a question. Imagine there are 10,000 rooms. I will be giving you two scenarios. Method one is nothing but check every room one after another. Another one is nothing but method two is nothing but using a smart searching method based on quantum principles. Can anyone say which method is easy? Can anyone say which method is easy? Bhargavachari, physical presence request for trust. Super, super money. Now my question is, if there is 10,000 rooms, is searching one by one is good, or searching, let us say, sending 500 students to a room, to 500 rooms is better? Which is the better method, Nana? That is what I want you to answer. It's your dinner time. Please don't waste your time. I want you to answer, Nana. Which is better? Method one is better or method two is better? That's it. Just that answer I want you to let me know in the comment section, Nana. Please, someone. Second option. Why? Because searching one by one room may take some time. Why? Because, for example, let us say that person is suffering from heart attack or some other disease, and he was fell on some room, and you wanted to go to rush to him, and he said just like he called you, and he just said, okay, I fell on some room, and he haven't mentioned any room number, which means we may cost by searching one by one, we may cost his life, but at a time many rooms, which will be very easy, and we may save him also, right? So that many possibilities are coming from only quantum computers, not classical computers. That is why we require quantum computing. Now, if you see here, we are having some applications, Nana. So the applications uh, include healthcare. So healthcare lo చూడండి అన్న, suppose scientists want to discover a new medicine, that is nothing but a corona అనుకోండి, corona vaccine అనుకోండి. They must study millions of possible molecular combinations, అన్న. This takes years using classical computers. I am mentioning this may take years, not days. So quantum computing may speed up these simulations that can help researchers discover discover medicines faster comparing to the classical computer. And in banking, finance, also bank process millions of transactions every day. They must predict risk. For example, ఒక ట్రాన్సాక్షన్ జరుగుతున్నప్పుడు end to end encryption నేను బ్రేక్ చేస్తాను. They may lose their complete economy, right? So to detect such type of risk and fraud, etc., we require quantum computing. Such that quantum computing will give you that particular security. And moving on to the cyber security, today our life, online banking, emails, and shopping rely on completely encryption, end-to-end encryption. So quantum computing can influence cyber security in two ways. First, it may break some current encryption systems. Second, can also develop stronger quantum safe encryption. So it creates both challenges and solutions also. Okay, the challenge is nothing but it will break our encryption. The solution is nothing but we'll be creating quantum safe encryption in the future also. Now moving on to the AI systems, AI system process huge amounts of data. So quantum computing may improve optimization problems used in machine learning also. So this is still an active research area. Now every researcher is focusing on. Now moving on to the weather forecasting. So weather depends on temperature, pressure, wind, humidity, oceans, and many other factors, right? So even small changes can affect the prediction. So quantum computing may improve this complex weather models, Nana, such that it will predict if I say in the next minute it will rain, it will rain. That is how the predictions of quantum computing will be going to be there in the future. And last one is nothing but space research. So scientists simulate planets, satellites, and spacecraft, etc. The simulations require enormous calculations, Rana. So quantum computing may reduce the computation time for some of these particular scientific problems. Now, if you see here, you need to remember this some key points. So a quantum computer uses qubits. Okay, it is based on the principles of quantum mechanics. So quantum principles are nothing but superposition, entanglement, etc. So it is designed for solving specific complex problems. It is not for your daily wear, daily using laptop systems. It is used for very complex problems. It is not a replacement of classical computers. It has the applications in AI cryptography that have been already discussed. Now, moving on to the best part of this particular session is nothing but what is the difference between bits and qubits? If you see here, so bits are nothing but the smallest unit of classical computer, but whereas Here we call it as bits in classical computers, on in laptops, on in phones that we are using now. But here we call them as qubits. So the qubits are nothing but the smallest unit of information in quantum computer. And in classical computers use what do you say uh, desktop, laptop, mobile, calculator, etc., will be using classical computers. But whereas in quantum computers, it's bit completely based on quantum mechanics, Nana. Now, if you see here, a bit stores either 0 or 1, but a qubit can store 0, comma 1, or a combination of both. Combination of both, I am calling it as superposition. So this is a very special property, Nana. We'll study in the next unit. And moving on to the fourth difference, if you see here, bits use electrical signals, and whereas qubits use quantum particles. What is that? Quantum particles. What are those quantum particles? Electrons, photons, trapped ions, superconducting circuits, etc. Okay. So if you see here in classical computer, we will be having only one output, either on or off at the same time. But it cannot perform super. That is why I mentioned it cannot perform super. But here it can perform superposition. Why? Because it will be exhibiting in many states at a time. So bits are independent, but whereas qubits can become entangled. Okay. Now classical computers works at room temperature, but quantum computers are very sensitive, Nana. Requirely controlled environments and all, without no disturbance should be there. So that is what we call it as coherence. So quantum computing law that is much required. Why? Because if it is reacting with environment, if it is involving with environment, mana information on the loss a chance undi nana. Okay. Now moving on to the last but not least, the classical computer or the laptops we are using or the mobile phones we are using, it will be completely working on the room temperature. But many quantum computers need extremely low temperature. That is what I've been mentioning. సో కొన్ని క్వాంటమ్ కంప్యూటర్స్ కి -273 degrees Celsius ఉండాలి. You just assume if I say you go and sit in a 0 degrees Celsius temperature, you can't. Okay, if our temperature is dropping below 10, we can't leave. But just imagine to perform a quantum operation in a quantum computer, it requires -273 degrees Celsius or 15 millikelvin. Okay, anta takku undale. That is what the major disadvantage or major setback of quantum computer with. That is what the major problem to build a quantum computer. Now moving on to the ninth reference, if you see here, bits are used in almost in any electronic device, Nana. Okay. Sorry, I want to discuss ninth, right? So bits are easy to manufacture, Nana, but whereas qubits are very difficult and expensive to build. Here in the 10th difference, bits are used in almost every electronic device, but whereas quantum computers are mainly found in research labs and specialized computer companies only. Bits always have one definite value, either on or off, but whereas qubits remain in quantum states until they measure. For example, if I am tossing a coin, it will be flipping in the air. It will be having two states at the same time, which is we call it as heads and tails. So that I am calling it as superposition. Okay. So if, for example, it is flipping in the air, I wanted to know whether it is heads or tails. What if I stop it? It will collapse, right? So that is what happening in the quantum also. When the qubit in superposition that is working in a quantum computer, when you try to measure it, it will be stopped and it will be coming to one state. Either it may be head or tail. Now, in classical computer, we'll be using logic gates. Nana, already you know, and or not, XOR. Okay, these are all nothing but the classical gate. But whereas in quantum computers, it will be some completely different. We'll be having poly X gate, poly Y gate, poly Z gate, a phase gate, Hadamard gate, C naught, etc., etc. I will be explaining this all those gates in the next chapters. Don't worry about that. Now moving on to the 13th reference. So classical computers can be best for everyday tasks like browsing videos, playing games, using your Excel sheets, etc., etc. But quantum computers are best for certain complex, specific optimization uh, optimization problems now that have been already discussed. Today's computers contain billions of bits, Nana. If you use if you are having laptop, that will be using a billions of bits. But whereas current quantum computers use tens or thousands of qubits only. We are not up to the mark as of now. We are using just as of now. 64 qubit system has been there implemented, but not thousands of qubit system. ఇంకా రాలేదు. 64 qubit system it is making miracles as of now. So technology is mature and widely available as of now. Why? Because laptop is everywhere available, phones are everywhere available. But whereas the quantum technology is still developing and improving. That is what the differences I want you to write in the examination. Now moving on to same differences ఉంటాయి నాన్న ఇక్కడ కూడా classical operator versus logical operations. So if you see here, I've been already mentioned classical operations have been used in classical computers, whereas quantum logical operations has been used in quantum computers. It will be completely working on bits, but whereas it will be using qubits, also known as quantum bits. Here we'll be using electronic logic gates, but here we'll be using quantum gates. And examples include and or not. Same thing that have been discussed. So two different topics and two different answers. So same answer you can write in different ways. That's it. So I'm not stretching much in this particular topic. Why? Because I've been done. So this is what uh, about unit one, Nana. So I want you to let me know in the comment section such that whether you are understanding or not. I will share this particular slides. Is that how you felt the session? I wanted to know the comment section, Anna. Can anyone name someone? So let us have some spicy in the end of the session. I have been finished. No issues. You'll be leaving. No issues. But the thing is, uh, can anyone answer me for this particular question? Uh, Abacus belongs to which generation? Can anyone please answer me in the comment section, Anna? Abacus belongs to which generation? You don't Google it, just answer me whether if it is wrong, also no issues. And the second question is who proposed the idea of quantum computing? And the third question is bit stores how many values? Can anyone please let me know in the comment section? Fine, Anna, fine, no issues. But the thing is, let me know in the comment section whether you are getting or not. Abacus belongs to which generation, Anna? That is what the answer I am expecting. Which generation Abacus belongs to? 3000 BC, good. Next question is nothing but super question, super answer, Anna. Who proposed the idea of quantum computing? Super, Upendra Kumar. Nice responses I'm getting. Super. Who proposed the idea of quantum computing? Who proposed the idea of quantum computing? Can anyone? No. 2000 BC, kaadu, Nana. It is 3000 BC. Gautam and Janvi have been answered the correct answers. No. Salman Khan, it is not the right answer. Peter Shor is not the correct answer. Who proposed the idea of quantum computing? I already asked this question in the live session. This is the second time I have been asking you. So let us finish in 5 minutes. No, I won't take your extra time. I wanted, I wanted that satisfaction that such that students are able to understand my session. I too want that self satisfaction rather than just finishing the topics. Just no, not Max Planck also. That is what Salman Khan. I you're getting my point. Madhu also getting my point. Richard Feynman, Anna. So you combine Feynman, Richard, and better Richard Feynman. Okay, Richard Feynman is the one who's proposed the idea of quantum computing. And now the third question is bit stores how many values? Bit stores how many values? Santosh, Santoshini, super, super. Good, good. You are responding good. That is what I expect from you people. If that happens, then quantum computing is very easy. If that is not happening, it is very tough. So can anyone know? Can anyone say me the third question? Bit stores how many values and what are those values? Just two questions left. Bit stores how many values and what are those? Two values, sir. Super Salman. And what are those two values? Bit stores how many values? What are those two values? Two values. I've got the answer. Pranavi, super, super, super Salman, super. Zero or one. That is what I want you to answer. Okay. So can a qubit be zero and one at the same time? The third question is, can a qubit can be zero or one at the same time? I want you to answer me for that particular question. Can a qubit can be zero and one at the same time? Is that possible? Zero and one at the same time? Qubit. I'm not answering. I'm not talking about bit. Yes. Okay. Upendra Kumar said yes. No, 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 no. Someone saying. So the answer is nothing but yes, Nana. Yes. A qubit can be 0 or 1 or at the same time it can be both. That both I have been called as superposition. Okay. No, no, no. You've been misunderstood that question. So qubit can be in 0 and 1 at the same time. That's why I'm calling it as superposition. Superposition ante ఏంటో కాదు నాన్న. Two states at a time, we call it as superposition. It will be having dual nature in quantum computers, but whereas in classical computers, it is not possible. We'll be having only one state at a time, either zero or one. Okay, a small correction you should make, you should understand. So, and also I am asking the last question of the session: which subject explains quantum particles? Physics, maths, or biology? Can anyone say which subject explains quantum particles? Is that maths, physics, or biology? Anyone, Anna? Can anyone explain which subject? Shivakumar said physics, okay. Bhargavachari also said physics. No issues. I think the answer will be physics, right? So the answer is nothing but physics, Nana. Why? Because physics is the subject which explains about uh, the quantum mechanics of the quantum particles. Super, super, Charan, Upendra Kumar, super. I've been appreciating the effort of Paranavi, Salman Khan, Madhu, and Save Trees, Shivakumar. Super, Nana, super. The response is so immense. This creates or this boosts me such that I can help you in many aspects. Okay. Uh, can anyone say, Nana? Can anyone say some simple answer question? Okay, no issues. So, Nana, thank you for the session. Sir, I like the way you are explaining. Charan, who is this? Okay, okay. I like the way I'm explaining. Okay, no issues, no issues, Anna. So I think the session is done from my side. So I think you got all the points in the particular session. In the future sessions, I will be showcasing you the max concepts, and I will be showcasing you how what are the fundamentals of superposition. That is very important topic. I don't want you to skip that particular topics. Let us be having some other lives before your exams too. So don't bother about the subject. Just trust me blindly. I will help you to push, and I will help you to get the CGPA. Okay, so that is what from my side I will be giving you, but I need some support from your side also. I want that number to be increased in the next live session. I won't force you to join, but the thing is, what makes me encouraging is that the n number of students increases, the more credibility I will be getting, and the more interest I will be getting in teaching some sort of topics that I can teach. Okay, rather than just coming and going without any without saying anything in the chat box. It is nothing, Nana. That is what I want. If you are giving me the time and you are investing your specious time for this particular session, it should not waste. From my side, from my end, I will be giving my best to give you the best. I have to utilize your best time. But the thing is, from your end also, you should utilize the best time that I am giving for you people also. Okay. Thank you, Nana. Thank you, Gautam. Super. I will be sharing this notes, Nana. No issues in the groups. I will be sharing after this class session completes. Okay. So have a great day, Nana. Have your dinner and have a great sleep. Thank you, Nana. I will be ending the live session. So if you are having any doubts, let me know in the comment section. No issues. I will be answering you at any time. Okay. Thank you, Nana. So I am ending the live session. So let కనీసము థ్యాంక్స్ అన్న or బాయ్ అన్న కనీసం కామెంట్ సెక్షన్ లో పెట్టాను the 20 people who are there in the live, please try to interact. I'll be ending the live session.